Hey there, welcome to a video covering linear equations and the way they are tested on the SAT exam. So what we're going to do is we're going to look at practice set 1, linear equations, and we're going to work out a few problems, one of each level of difficulty. So an easy one, a medium one, and a hard one. Hard ones are actually not hard, they're just a little weird. So I'm going to show you the approach for some of these problems. So let's start with a simple one. We will do number 1. So what I'm going to do is I'm going to copy and paste this problem onto a program that will allow me to scribe. Perfect. So let's see what this question is asking. Which of the following equations represents the line shown in the graph? Now, one thing you're going to want to take note of when working on multiple choice problems, whether it's SAT or ACT or really any exam, is that the words which are the following typically will imply a process of elimination technique, meaning that we're going to want to look at the choices pretty much right away and go through process of elimination. So instead of looking at the line, trying to figure out the slope and the y-intercept, let's just look at the choices to see which ones make sense and which ones don't make sense. Of course, only one will make sense because there's only one answer, and 3 of these choices won't make any sense. So if I look at the first choice, and conceptually, hopefully you remember the equation of a linear function, y equals mx plus b. This is a linear equation. M equals the slope, the coefficient of x, of course. B is the y-intercept. So when I look at the first choice, 1/4, 1/4 would be over here for my y-intercept. I don't like that. And I don't think the slope is 6 anyway. That means you have to rise 6 and run 1. Remember, slope is rise over run. So that's not going to work for us. I do like B. The y-intercept is 6. Looks like the slope is 1/4. That could work. But I don't like C because the slope here is 4, and that's a little too much. I don't like D, so I definitely would go with B in this case. So now we'll move on to a medium level problem. So let's do one that requires a bit of interpretation. So this will be number 9. So there's a graph that goes with it. And here's the question and the choices. And actually, that might work a little better for us. Move it a little closer. Perfect. So let's read the question here. A car rental agency charges a per-day rental fee which includes a daily mileage allowance plus a certain amount per mile driven over the allowance. The graph above compares the miles driven over the allowance and the total cost for a 3-day rental. What does a c-intercept most likely represent in this scenario? There's a lot of information happening here. So we need to dissect the problem so we don't get confused. So what's the rental car agency charging us for? A per-day rental fee plus a certain amount per mile driven over the allowance. So, and the per-day rental fee includes a daily mileage allowance plus a certain amount per mile driven over the allowance. Okay. And here they give us the total cost for a 3-day rental. That's actually going to be useless information, and I'll explain why in a little bit. So what does the c-intercept represent? Now let's look at the graph. C is going to be like y, and the miles driven is going to be like x. So basically, they're asking for what does the y-intercept represent? And of course, the y-intercept here looks like it's pretty close to 64, probably about 63, we'll say. So clearly, the cost of the car, we'll use C, instead of y will equal m times x plus b, or in this case, or well, we'll use y again, whatever. So the equation of a linear function, but basically it will be the cost, our slope, times the miles driven, plus the c-intercept. So the c-intercept basically tells us how much a car is going to cost if we don't drive any miles. So it's going to essentially be part of the per day rental fee, the daily mileage allowance. So it's not the miles driven. It's not the total cost. So in this case, and it's not to be a penalty, that's just really weird and bizarre. But D is interesting because it says the total cost of a 3-day rental, assuming the car is not driven over the allowance. So, because it's not the per day rental fee for renting the car. So basically, if X were 0, you're not driving over the allowance. The total cost would be basically your c-intercept. So a bit of interpretation. These are a little strange, and we're going to have to spend a little more time on this. But essentially what you want to do is break down the problem into as many parts as you can. In the 3-day rental, you know, they said here that the graph above compares the miles driven over the allowance and the total cost for a 3-day rental. It's already built in to the graph, so that's why I didn't have to do anything special the 3 days. And D made the most sense because if X were 0, you're not going over the allowance because X represents the miles driven over the allowance, as we see in the x-axis here. So basically when X is 0, that's what the c-intercept is going to represent. Okay, let's do one more. Let's do a tough one. Let's do a free response one. We'll try number 20 here. And by the way, if you see a calculator symbol next to a problem, that means a calculator is allowed. On the SAT, there is a section where calculator is allowed and a section where calculator is not allowed. So for these worksheets, if you see a calculator symbol next to the problem, feel free to use a calculator. If not, you shouldn't unless it's stated in the beginning of the packet. Okay, lastly, number 20. So I'd like to know about A minus B. So we have an equation here. So typically what you want to do is try to clean it up. And also, they say it has infinitely many solutions. We'll come back to that in a little bit. But if I clean this up, you get 3x minus 2 because I'm distributing the 1/2. And if I do it the minus, I get this. If I clean up the left side even more, 4x minus 5 equals ax plus x plus b. If I move the x over to the other side, I wind up getting this. Now, in order to get infinitely many solutions, what's going to happen is that you need the left side to equal the right side all the time. So in order for that to happen, A would have to be 3 and B would have to be negative 5. Therefore, the left side equals the right side. Everything cancels. You get 0 equals 0. So that's what infinitely many solutions would imply. So, of course, 3 minus negative 5 is 8. And that would be the answer for this problem. You can put it anywhere you like, and you bubble 8 right below. So that covers the video on linear equations.